Hey, calculus students. I've gotten interrupted many times while trying to make this video for you, so here goes nothing. We're going to do example 3 here, which is very similar to your homework tonight. In the homework, it wants you to do an analysis of the particle's direction, which is the same as its velocity, its acceleration, its motion, which means speeding up or slowing down, and the position. So for your homework, you can make similar charts to exactly what we're going to do now. So this problem says that a particle is moving along a horizontal line with position function s of t equals t cubed minus 9 times t squared plus 24t plus 4. So I made sure to label here that this s of t function is the same as the position. It's not speed, it's position. Okay. So in order to make the analysis chart of the velocity, I had to first find the velocity, and I did that by taking the derivative of this position function. So I took the derivative and got 3t squared minus 18t plus 24. And like I said in class, we need to be able to find the important points for the important point values of t in this velocity function. And to do that, we set the velocity function equal to 0 to solve for t. Because remember, when the velocity is equal to 0, that means that the particle has stopped. So these stopping points are important points because then we can look to the left, to the right of the stopping points to see if it's changing direction. So set your velocity function equal to 0, and now we're going to factor to solve. So I'll start by simplifying this by factoring out a 3, and I'll get 3 t squared minus 6t plus 8 equals 0. Then I can factor this thing again, 3t minus 4 times t minus 2 equals 0. And then I solve both of those for t. T equals 4 and t equals 2. So these are my critical points in the velocity chart that I'm going to make. So I can do 1, 2, 3, 4, and I'll go 5. So my important points are at 2 and 4. And these are the points where the velocity is equal to 0, so the particle has stopped. So before and in between these stopping points, I want to see if the velocity is positive or negative. So to see if it's going left or going right.
Attention students on Central Demetrio, if you are on campus, please report to the main office. On Central Demetrio, if you are on campus, please report to the main office.
Okay, so I can do that by plugging in like the value 1 here. So I'll plug 1 into our velocity function, and I get 3 minus 18 plus 24. That's a positive number. So I know that my velocity is positive here, so it's moving towards the right. And then I can plug in 3 here. I get 3 times 9 is 27 minus 18 times 3 plus 24. That is a negative number. And then if I plug in 5 here, I get a positive number. Also, when you're looking to know if these numbers are positive or negative, you can plug it in up here, or you can plug it in down here, whichever is easier for you. So you just plug the number in, see if you get a positive or negative number, and you don't have to say what the number is, just what the sign is. Okay, so now we're going to examine the acceleration, and I know that acceleration is the derivative of the velocity function. So acceleration at t is the derivative of that, so it's 6t minus 18. And again, to find the critical points, I'm going to set it equal to 0, and I get t equals 3. Okay, so I want to make sure when I label my critical point, I kind of keep it in line with my velocity graph. You will see why soon. So here on my velocity graph is the point 3. I can label that here. So here's 3. It's our critical point. And again, I just want to look to the left and to the right of this to see what my sign is here. So if I plug in 1 into here, I get 6 times 1 minus 18. That's a negative number. If I plug in 4, I get 6 times 4 minus 18 is a positive number. So I can see that to the left of the critical point, it's negative, so it means the particle is accelerating to the left. And to the right of the critical point, it is positive, so it's accelerating to the right. Cool. So now, in order to determine its motion, meaning whether it's speeding up or slowing down, I'm going to bring all my critical points down into one graph and examine it there. So I'm going to bring down this critical point of 2, this critical point of 3, and the critical point 4. Okay. And remember, if we look back at the chart, oh, it's actually over here. If we look back on the chart we made in class, we used the signs of the velocity and acceleration to figure out if it's speeding up or slowing down. So we know that if they have opposite signs, they're slowing down, and if they have the same sign, they're speeding up. Okay? So we look back here, and we can look at our charts and see that here, before 2, they have opposite signs. When they have opposite signs, it means it's negative, which means it's slowing. Slowing. Okay? Here, they're both negative. 2 negatives make a positive, so you know it's speed. Speed up. Between 3 and 4, we have negative and positive. Negative and a positive make a negative, so it's slow. And then after 4, it's positive and positive. 2 positives are positive, so I know it speeds. Speed up. Okay. So I have a lot of information from this graph, and I can use it now to model the position of the particle. Okay. So in order to graph the position, I'm going to again use my critical points and the velocity, but I also want to make sure to start at time 0. So for my position, I want to look at the position at t equals 0, 2, and 4. I want to look at 2 and 4 because, as I can see from the velocity, these are 2 points where the particle here is moving to the right, then it stops, and it starts moving left, and then it stops, and then it moves to the right. So this is where we're going to get the particle like jumping and going back and forth and stuff like that. So let's look at t equals 0. So I need to plug t equals 0 into my position function, which is up here. So when t equals 0, the position is at 4. So we'll put 4 on our table back here. This is t equals 0. And looking at my velocity graph, at t equals 0, I know that it's moving to the right. So it's gonna, I'm just going to say right away it's going this way. Let's see how far it goes though. So let's plug in our next important point of 2 into the position function. And I'll do the mental math. So I plug in 2 here, and I get 24. So at t equals 2, it gets 24. So from t equals 0 to t equals 2, it goes all the way over here. So it's moving right. And then looking at my velocity graph, it stops, and it goes negative. So negative means that after 2, it's going to turn and start going left. So let's see where it ends up at t equals 4. So again, I'll plug in t equals 4 into my position function, do some mental math, and it goes to, this point here is 20. So at t equals 4, we're at 20, so I go this way. And then going back up to my velocity graph, after 4, the sign of the velocity goes back to positive. So I know that the direction is going to turn around and turn right again. So I can kind of follow the position function with the velocity function. So it's positive, it's going right until time 2, where it stops, turns and goes left until time 4, and then it stops and it turns again and it goes right. And then it's just going to keep going right from there. Okay, so this is what you're doing on tonight's homework. Each of these will be worth 3 points, meaning each problem is worth 12 points. Please send me a message on Schoology if you have any questions. Alright? Have a wonderful evening. I'm glad. I hope this video works. I'll be very upset if I have to make it again. Okay, bye.